Hi, I'm Rich with insideHPC. We're here at the Intel booth at SC12 in Salt Lake City, and I'm here with Gergana from Intel. So, Gergana, what are you showing here today in terms of your demo?
So we're actually talking about the Intel Cluster Studio XC. So we had a new release last week, and so that's where we have the tools right here. I'm actually running on a pretty small 4-node cluster. So our big announcement was the Intel Xeon Phi card. So that happened, a coprocessor card. So that happened on Monday. And so one of the things that we did is we took an application called MiniFE. It's doing finite element analysis. So it's a very small, it's a miniature version of a larger code. And so what we did is we ported it to the Intel Xeon Phi card. So we tried to do, our library, the Intel MPI library, runs natively on the coprocessor card. It runs natively on just the regular Xeons. So what we try to do is run in symmetric mode. So we do some MPI ranks on the host and then some MPI ranks on the card. And so we try to figure out what's the best balance between the workloads. And so one of the tools that we use to do that is called the Intel Trace Analyze and Collector, and that's what I'm doing the demo of today.
That sounds good. Can we take a look?
Sure, definitely. So what you're seeing here is a trace of the MiniFE application. So the way that the tool generally works is as the MPI application is running, it collects information about what events you're encountering. So all the blue sections that you see right here are actually all the work that you're doing, and then all the red sections are the communication parts. So generally in a well-implemented parallel application, you want to see less red and more blue, of course. What we try to do, so we trace this information. So we trace the MiniFE application, and so this is the sort of the workflow from start to finish of the application. So it's doing a few iterations. You can see the pattern here. But what becomes really obvious is that some of the processes are actually doing a lot more work than others. So you can see that there's some, so on the y-axis here, you can see all of your ranks, MPI ranks, and it's a fairly large job. I'm running over 100 MPI ranks. So you see some are waiting around a lot for others to finish. So some of the things that I can do with this tool is I can actually sort the data based not only on the ranks that I'm running, but also on the nodes that I'm running it on. So that was just an easy click at the bottom. So I can see if I open up this all nodes, so I can see that so I can see first off a list of all my machines that I ran this on. So this seems to be just, so I have a node, and then on each node I have 2 Intel Xeon Phi cards attached to it. And so I have 4 sets of those. And I can also see the MPI ranks for each particular machine. So if I do the aggregation based on the nodes, then my viewpoint changes, and it becomes really obvious that what I'm actually doing in this case is I'm actually putting a lot of work on my mic cards, on the 2 mic cards that I have attached to my host. And so I'm actually forcing my host to wait around for them to finish. So this job run, so you can see at the top here, was actually doing 24 MPI ranks, and each rank spawned 8 threads. So it's a hybrid MPI OpenMP job. So what I probably need to do is maybe do a little bit of load balancing. So the load imbalance is actually really obvious if you look at the bottom here as well. If you look at the group MPI and then you sort it, you see that it's very irregular. So probably what I need to do is take some of that work off of the mic cards, off of the Intel Xeon Phi cards, and put it back onto my host. And I actually have a comparison trace of that, which is at the bottom here. And you can see, so this is literally the same application. I didn't actually have to change anything. The only thing I changed is now instead of running 24 MPI ranks, I have now decreased that number. I'm now running 16, but I'm now starting 12 OpenMP threads for each rank. So you can see that the load balance for that is actually a lot better. So I can actually scroll down a little bit, and you can see that it's actually a lot better in terms of the chart at the bottom, the load balancing chart. So the segments, the MPI segments are actually a lot more even.